All right, my fellow statisticians, there's one more extension to Lesson 5.4 that I wanted to make sure I talked through with you if you're at all busy working on MyLabs Plus over your enjoyable snowy spring break. And it has to do with when you use what's called a finite correction factor. Now, this isn't hugely important, but it is something you need to be familiar with. And so this is basically something that is used when you're dealing with a problem about a sample average and the sampling distribution for sample averages. You use a finite correction factor when you're taking a sample from a population and your sample size is so large relative to the size of the population that it makes up more than 5% of the population. So the first thing you want to recognize is that this finite correction factor is used when you take your sample size and you divide it by the population size. We know little n is used for the size of a sample. Big N is used for the size of a population. If you're sampling without replacement, which you typically are, you want to take the size of your sample and divide by the size of the population. And if that proportion is greater than 5%, 0.05, you need to use this finite correction factor. Okay? And we'll demonstrate this with an example. Now, what the finite correction factor does is it says, okay, the standard error of the sampling distribution isn't just sigma over root n, but rather you multiply that by the finite correction factor, which is the square root of the population size minus the sample size over the population size minus 1. Now there's a lot of understanding that goes behind why this formula is used as a finite correction factor, but it's such a minimal part of what we are doing here in this introductory statistics course that I'm not going to get into that, okay? So when you think about a situation where you're asked to find the probability of getting a particular sample average or more, or a particular sample average or less, we know that step 1, we find the mean of the sampling distribution, which should equal the mean of the population, and step 2, we find the standard error of the sampling distribution, which should equal the standard deviation of the population over root n. Well, when your sample size is at least 0.05, when your sample size is at least 0.05 or 5% of the size of the population, that means you're removing a pretty large proportion of the population. What you have to do then is factor in your finite correction factor. So let's demonstrate. Let's say that we take a sample of 45 from a population whose size is 800. And you want to determine first if you should use the finite correction factor. Well, once again, we're going to want to take our sample size and divide by our population size and see if that is more than 0.05. In this case, you see when you divide that, it is slightly more than 0.05. So when we get to step 2 of finding the probability of getting a particular sample average, we're going to need to factor in our finite correction factor. So let's say that this population has a standard deviation of 0.009. So when I get to step 2 and I want to find my standard error of my sampling distribution, I'm going to need to use my finite correction factor. So I'm going to have to take sigma 0.009 and divide by my square root of my sample size, in this case 45. But I'm going to have to multiply that by my correction factor. So my population size 800 minus my sample size 45, sorry, I've run out of room on the screen, divided by my population size 800 minus 1, which would be 79. And when you calculate that, you should get a standard error of 0.0013. Now, had you calculated it without the finite correction factor, I want you to notice, so if you just did the 0.009 divided by the square root of 45, I want you to notice that you get a very similar value. In fact, when you round it to 4 significant figures, you get the same value. That is in large part because this was just our sample was just slightly more than 5%. If it's like 10% or 15% or 20% of the population, then that finite correction factor can have an influence on the standard error of your sampling distribution. Once again, if you have any questions, please don't hesitate to email me either at my school email or through Blackboard.